Hello guys, this is Sir Lincoln. Today we're going to do question number 5 of 0642 February March 2025, which is chemistry paper 4 in extended paper with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Complete table 5.1 to show the number of protons, neutrons, and electrons in the manganese atom and the calcium 2+ ion. So the manganese, 55 manganese, from the periodic table, manganese is an atomic number. We are already told that manganese is an atomic number of 25, so we can include it here, 25, and calcium is an atomic number of 20. So the number of protons is equal to the atomic number. The atomic number is also known as the proton number. So the number of protons in manganese is 25, and the number of protons in the calcium is also 20. So the proton number is equal to the atomic number. The neutrons, we use the formula mass number is equal to number of neutrons plus number of protons. So to get the neutrons, we say neutrons is equal to mass number minus proton number. We just make the neutron number the subject of formula. So the number of neutrons for manganese, we are going to say 55 minus 25. 55 is the mass number for manganese, 25 is the proton number. So 55 minus 25, we get a 30. For calcium, we are going to say 42 minus 20, we get a 22. Then the electrons, for manganese, since it is an atom, which means it has not lost or gained electrons, it is still a neutral atom. So the number of protons is equal to the number of electrons. So we have 25 electrons. For calcium, it is charged Ca2+. 2+, it means it has lost 2 electrons. So from the original 20 electrons, which are equal to the proton number, we are going to subtract 2 electrons. So if we say 20 minus 2, we get 18 electrons. So the number of electrons in Ca2+ is 18. The next question, it reads, manganese forms several oxides. The formula of some of these oxides are shown. So you have MnO, Mn2O3, Mn3O4, MnO2, and Mn2O7. Suggest why manganese is expected to form colored oxides. So the reason why manganese is expected to form colored oxides, it is because it is a transition element. This is why it is expected to form colored oxides. So transition elements or transition metals, they usually form colored compounds. Then the next part, state which other property of manganese is shown by the formation of several oxides. So for it to form these different oxides, it means that it has variable oxidation states. So that's the reason why it is able to form several oxides, because this oxygen state here is different from this one, it is different from this one, and the rest. Then item 3, state the formula of manganese 2 oxide. So the number in brackets, it shows the charge of manganese. So here we have Mn 2 plus. The oxide is the oxygen ion, which is O2 minus. So if you look at the charges, this is 2 plus versus 2 minus. So we can see that we only need one oxide to balance this 2 plus from manganese. So they are equal to each other. So the formula just becomes MnO. Or if we use the method of swapping and dropping, MnO2 minus, and if you drop this 2 from oxygen, comes to manganese, and this 2 from manganese coming to oxygen, becomes MnO2, and since these numbers are equal, we can reduce it such that it becomes MnO. So the formula for manganese oxide is MnO. The next question, it reads, Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as the reducing agent. Define the term reducing agent. So the term reducing agent, this is a substance which reduces another substance while it is oxidized itself. So itself, it is oxidized, but it reduces another substance. So we are going to see that on this next question. So the next question, it reads, complete the symbol equation by inserting the formula of the missing product and balancing the equation. So this is the equation. We have our Mn3O4, aluminium, and the product here, and Mn. So the product which is going to be formed, we are going to look at the equation. Since we are told that aluminium is the reducing agent, so it means this is going to cause the reduction of manganese Mn3O4. So one of the definitions of reduction, it is the loss of oxygen. So here our manganese is going to lose oxygen to aluminium. And the formula for aluminium oxide, we can calculate it using the method of swapping and dropping. So it's aluminium versus the oxide, Al3 plus versus O2 minus. So if you rewrite here, the 3 from aluminium, it goes to oxygen, the 2 from oxygen, it goes to aluminium. So the formula of the oxide, which is formed between aluminium and oxygen, is a Al2O3. So this is the product. Then to balance the equation, so in order to balance this equation, we can use one of the tricks which is used to easily balance equations, which is balancing isolated elements like this. Here, aluminium is isolated and manganese which is isolated. So we can end with balancing aluminium and manganese. So let us look at oxygen. We have 4 oxygen atoms on the left and 3 here. So what we can do is to switch the numbers such that we balance the oxygen atoms. So here we can multiply by 4 so that it becomes 4 multiplied by 3, and we get 12 oxygens on the right. Then to get 12 oxygens on the left here, we then multiply this by 3. So now on the left hand we have 3 multiplied by 4 oxygen, which is 12. And these numbers on the right, if you This 4 also affects aluminium, and this 3 affects manganese. So 3 multiplied by 3 manganese on the left, it means you have 9 manganese atoms. On the right, we are going to put a 9. So it is easier since this is the stand-alone element. On the left, we have on the right aluminium 4 multiplied by 2. This is 8 aluminium atoms. Then on the left we have 1, so we are going to put an 8. So now the equation is balanced. Part D, the question reads, manganese 4 oxide reacts with dilute hydrochloric acid as shown in the equation. So manganese 4 oxide plus hydrochloric acid, we have manganese 2 chloride and water and chlorine gas. Calculate the volume of chlorine gas formed in cubic centimeters at RTP when excess manganese 4 oxide reacts with 50 cubic centimeters of 0.2 mole per cubic decimeter hydrochloric acid. Use the following steps. So I'm going to follow these steps. So the first one, calculate the number of moles of hydrochloric acid used. So here we need to identify the quantities of hydrochloric acid that we have been given. This is the volume and this is the concentration. So in order to find the number of moles given the volume and concentration, we use the formula which says that number of moles is equal to concentration times volume. Then we have to pay particular attention to our units. This concentration is given in mole per cubic decimeters, and this volume is given in cubic centimeters. So you have to make sure that there is a consistency of units. So we are going to take our concentration, which is 0.2 multiplied by our volume. In order to convert our volume to cubic decimeters, we divide by 1000. So it is going to be multiplied by 50 over 1000. So if you compute this, we're going to get 0.2 multiplied by 50 over 1000. We get 0.01. So this is 0.01 moles. So this is the number of moles. Then determine the number of moles of chlorine gas formed. So to determine the number of moles of chlorine gas formed, we are going to use the stoichiometric ratios. Here we have 4 moles of hydrochloric acid which react to produce 1 mole of chlorine. So you can see that the ratio here is 4:1. So in order to get the number of moles of chlorine, we divide by 4. So the number of moles of chlorine gas are equal to 1/4 multiplied by 0.01, and here we get 0.0025. So this is the value which you get. I've already calculated it, so I'm just going to use the values that I've already calculated. Now, the last part, we need to find the volume of chlorine which is formed. So you will need to use the relationship which states that 1 mole of any gas is equal to 24 cubic decimeters. This is the molar volume. So to change this to cubic centimeters, since our answer, our question requires us to calculate the volume of chlorine in cubic centimeters, you can just use this, change this ratio to a volume in cubic centimeters. So therefore gives us 1 mole is equivalent to 24,000 cubic centimeters, using the relationship that 1 cubic decimeter is equal to 1,000 cubic centimeters. So to convert a volume in cubic decimeters to cubic centimeters, we simply multiply by 1,000. So in order to get the volume which is occupied by 0.025 moles of chlorine gas, we simply multiply this value with 0.025. So the volume of Cl2 is equal to 0.0025 multiplied by 24,000. And if we compute this, we get 60 cubic centimeters. So that is the value which we get. Okay, so the last part of the question, it reads, describe the test for chlorine gas. So the test for chlorine gas that we use a damp litmus paper. And the observation that we make is that the litmus paper is bleached, or we may say that it is tanned white. The last part of the question, it reads, explain in terms of collision theory why decreasing the temperature decreases the rate of this reaction. So temperature and kinetic energy are directly proportional to each other. So if you decrease temperature, the kinetic energy decreases. The kinetic energy of the particles decreases, meaning to say they will be moving at lower speeds, and the frequency of collisions, also decreases. Since our particles are no longer moving so often, they no longer collide more often per unit time. For example, if they were colliding 20 collisions per second, if their kinetic energy is reduced, they start maybe to collide 15 collisions or even lower collisions per second. And if again the frequency of collisions decreases, and when they collide fewer particles have energy which is equal or greater than the activation energy. So for a reaction to successfully take place, the molecules which collide with each other must have enough energy such that a reaction is initiated. So the activation energy, if there is an amount of energy which is equal or greater than the activation energy, then the reaction will take place. But here in this case, fewer particles will have energy which will be equal or greater than the activation energy. So ladies and gentlemen, we have reached to the end of this question. Stay tuned for more. Don't forget to like, share and subscribe.